Welcome to MBAs Teach Econ. Today we're going to build on our first lesson where we introduce the basic building blocks of the Solow Growth Model. And this is where we left off. So when we're looking at this picture, just to review, we have three critical lines in the Solow Growth Model. We have our overall production function, which is the top line here. We have our depreciation line, which is our depreciation rate D times K, which is here. And then we have our savings line, which is a savings rate times our overall level of GDP. So let's just take a look at an arbitrary level of physical capital. And I'm going to call this K naught. How would we determine what our total savings is at this point? Well, we would just start at K naught and we would trace up to our savings line and then move horizontally to our y-axis, and this would represent our savings, which we know from this relationship where S equals I, this also equals our level of investment. Similarly, our total consumption across the economy, which would be C plus G, or if we assumed away, which sometimes happens in Intro to Econ, if we assumed away government spending, this would just be consumption. This is based off of this identity right here. We can see that this would be our level of consumption in the economy. And then the total level of production, we would just trace again horizontally to our y-axis. This would be Y, and this would be S times Y, or our savings. Now something else is important to note here. You can see that our total level of investment at this point is greater than our total level of depreciation. So if we think back to, and I'll put a star next to it, this equation, we know that if K now is greater than K last, this will happen when investment is greater than total depreciation. Well, as long as this savings line is on top of this depreciation line, we're going to have an instance where K is going to steadily increase. So K1 would be here and K2 would be here, because everywhere in this area of the picture, we're at a place where our investment is greater than our depreciation. Therefore, our steady state equilibrium will occur where S times Y equals D times K. To determine what our steady state equilibrium physical stock is, we would just trace this down to the horizontal axis. And we'll call this K star. And then to find our steady state GDP, remember to trace up to the actual production function. Oftentimes, students will trace horizontally from this point. That gives us our steady state level of savings, but we have to trace up to the production function to get our steady state level of GDP. So this is where we are right now. We've been able to identify a steady state equilibrium at this point and understand what our steady state level of physical capital stock was, K star, our steady state level of GDP, Y star, and our steady state level of total savings, which would be our savings rate times our Y star. So if leaders in an economy know this, how might they increase GDP in their economy? Because that's what they want to do. How can they encourage economic growth? So the first way they might do that, which we've seen in China over the past 30 years, is increase their savings rate. So you can think, if they increase savings rate, what's going to happen to this picture? Well, our savings rate will increase, but everything else will stay the same. what's going to shift is our steady state equilibrium. So as we increase our savings rate, let's just do our initial increase. We can see that S2y, and again, y's are staying the same. The only thing that's changing is the S2 here, leads to this new steady state, which would lead to a higher level of GDP. And countries can continue doing this. They could continue increasing their savings rate, but what you'll notice is the law of diminishing returns starts to come into play. They start accumulating more physical capital stock, but so we can see that there's limits to increasing a savings rate because we fall into the issue of diminishing returns. You can't sustain growth in the long run simply by increasing your savings rate. If we think back to the equation for our production function, we have A, which is a factor of our technology, times the function of human capital and physical capital. And both of these variables succumb to this law of diminishing returns, human capital and physical capital. So that leaves us with A. So what happens if a country increases its technology, develops technological improvements that help them do things more efficiently? Well, in this picture, what would happen if A increased, then we would have a new production function, and I'm just going to call it A naught. Our savings rate is staying the same, but since we have a new production function with a higher value due to this new A, our savings line would also increase. And you can see what's going to happen. Our steady state equilibrium is going to move from this point, K naught, and this being our initial production function, Y naught, to this new steady state equilibrium, K1, and this new GDP, Y1. This simple story illustrates how countries can sustain long-run economic growth and why the Solow growth model is so important in illustrating that phenomenon.
And until next time, it's been MBAs Teach Econ.